The real number system. The real number system helps us make sense of ratios. In the real number system, we have rational numbers. Ratios live there. We also need to recognize when we're measuring the world with ratios and when we're measuring the world using fractions, because it changes how we can manipulate the object. If it's a ratio, we have to manipulate it different than if it's a fraction representing a single value. Is it comparing two quantities or is it just a single value? And that changes the way we're working with them. So that's why we're focusing on the real number system while we're also learning about ratios. A rational number, and let me get my handy dandy. Okay. A rational number is in the form of A over B, A divided by B, where A and B are integers. So any value that can be represented by two integers and a division operation. So division and multiplication are tied together in the rational numbers, so they invert each other. Ratios are multiplicative by nature. So one ratio we have here is 9 to 17. This could be 9 cats to 17 dogs, or 9 cats to 17 animals. It could be part to part, which would be cats to dogs, or part to whole, which would be cats to all animals, if those cats were included in the animals. 2.3, 2 and 3 tenths, 2 and 3 tenths of a dollar, 230 pennies out of 100 pennies per dollar. Ways of thinking about the way these are ratios. They're comparing quantities. 0 is a rational number. Nobody from our advisory participated in the Spirit Day challenge for the day or something. Okay. And that would be 0 part to the whole, which would be however many students in the advisory. Irrational numbers, okay? Irrational numbers cannot be expressed as the ratio of two integers. So pi is a transcendental number. It's an irrational number. It never repeats and it never terminates, never ends. An irrational number is any decimal that doesn't have repetition or an end. Often those numbers can be found by taking the square root of a non-perfect square. So the perfect squares that are in front of 7 are 4, because the square root of 4 is 2, and then the square root of 9, because the square root of 9 is 3. So the square root of 7 lives between 2 and 3, but it's irrational. We don't know exactly what its exact value is. An integer is the set of positive numbers, negative numbers, and 0. It has no decimal or fraction component, so it's the whole numbers and their opposites. 63 and negative 63, 12 and negative 12, negative 98 and 98. 0 is an integer. Whole numbers are the set of non-negative integers, so it is also a type of number without a fraction or a part. 0, 56, 100, their negatives are not included. The natural numbers are the counting numbers greater than or equal to 1. I find it unfortunate that 0 is not included in the natural numbers. I think that 0 is very natural, but it is not included. So now you can go to your student workspace and attempt to identify or label which of these are whole numbers, natural numbers, integers, and rational numbers. You could, grab a star of some sort. You can always use your snip and sketch copy. So if I grab that, I can copy it and then paste it wherever I think there's a rational number. So I think that's a rational number because there's a ratio. 2.3 can be written as 23 over 10. 0 is a rational number. This is not a rational number. It was on the irrational slide. This ... Let's see. Irrational notation ... Ellipses. Let's see. I don't know technically if those ... are proper notation for irrational numbers, but I would Yeah. I will check that. And I don't believe that an irrational number, I don't know if that automatically implies that a number is irrational. I guess it does. There it is. Okay, but don't rely on that. I would just make sure that you're paying attention to if there's no repetition. So that's hard to tell. 256. You could write that as 256 over 1,000, but the dot 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 is implying that there's more there. So that's not rational. Pi square root of 7, not rational. These are all rational. Okay, and so on. Okay. So next video will be the summary page, and I wish you all luck. Email me with any questions.